Look up. What do you see? Blankets of white, dramatic towers, delicate wisps painting the sky. We see them every day, but how often do we truly see them? Welcome back to the Geographic Eye, where we explore the wonders of our planet. Today, we're turning our gaze upwards, beyond the mountains and coasts, to unravel the secrets of the sky's silent storytellers, clouds. They're not just decoration. Clouds are the engines of our weather, the architects of climate, the vital distributors of Earth's most precious resource, water. They shape landscapes, influence tourism, and hold clues to our planet's future. Get ready to see the sky in a whole new light. So, what exactly is a cloud? It's surprisingly simple, yet endlessly complex. It all starts with evaporation. The sun heats water on Earth's surface, oceans, lakes, rivers, even plants, turning liquid water into invisible water vapor gas. This warm, moist air is lighter, so it rises. As it climbs higher into the atmosphere, the air pressure drops and it cools down. Cool air can't hold as much water vapor. Eventually, it reaches the dew point, the temperature where the vapor is forced to condense back into tiny liquid water droplets. Or even ice crystals if it's cold enough high up. Billions upon billions of these microscopic droplets or ice crystals cluster together around tiny particles like dust or salt. And voila! A cloud is born. It's essentially a massive, visible collection of water or ice, floating in the air. Not all clouds are created equal. Meteorologists classify them based on their shape and crucially, their altitude. Let's meet the main families. 1. The low-level crew. Surface, 6,500 feet/2,000 meters. Stratus. Our classic overcast day. A uniform, gray layer that often brings drizzle or mist. Think moody coastal scenes or winter gloom. Stratocumulus. The most common cloud globally. A bumpy, rolling layer, like a textured blanket. Usually not heavy rain, but can bring light showers. Cumulus. The iconic, fair-weather cloud. Puffy, cotton-like, with flat bases and rounded tops. They form as warm air bubbles rise. Mostly harmless, but can grow. 2. The middle storytellers. 6,500 feet to 20,000 feet/2,000 meters to 6,000 meters. Altocumulus. Like a flock of small, puffy clouds mid-sky. Often appear in waves or sheets. Can signal changing weather ahead. Altostratus. A thinner, grayish veil covering the sun or moon, making it look hazy. Often precedes steady rain or snow. 3. The high-flying ice wizards. Above 20,000 feet/6,000 meters. Cirrus. Wispy, hair-like clouds made of ice crystals, often the first sign of an approaching warm front, and potential weather change within 24 to 48 hours. Cirrocumulus. A delicate patchwork of very small, white puffs. Creates that beautiful, mackerel sky. Fair weather, but high up. Cirrostratus. A thin, milky sheet covering the sky. Sun or moon shines through, often creating halos. Another sign of approaching moisture. 4. The vertical giants. The weather makers. Can span all levels. Cumulonimbus, the king of clouds. The mighty thunderstorm cloud. Towering vertically through all layers, with a characteristic anvil top spreading out. Brings heavy rain, hail, lightning, thunder, even tornadoes. The ultimate engine of severe weather. Nimbostratus, the classic rain cloud. A thick, dark, uniform layer that blots out the sun. Brings persistent, widespread rain or snow. Often hangs low but can extend upwards. Clouds are far more than sky scenery. They are fundamental players in Earth's systems. The water cycle superhighway. They are the vital transport system, moving evaporated water from oceans over land, releasing it as rain or snow, replenishing freshwater sources we depend on. Earth's thermostat. Clouds have a huge, complex impact on temperature. Their bright white tops reflect a massive amount of sunlight back into space, cooling the planet, albedo effect. But, they also act like a blanket, trapping heat radiating from the Earth's surface, greenhouse effect. Which effect wins depends on the cloud's height, thickness, and type. Understanding this balance is critical for climate science. Weather dictators. They are precipitation. No clouds, no rain, no snow. They dictate sunshine versus shade, humidity levels, and drive wind patterns. They define our daily weather experience. Tourism and geography. Think about it, a mountain view hidden by stratus versus revealed by clearing skies. The drama of a cumulonimbus over the savanna. The ethereal light filtered through cirrostratus. Clouds shape the landscapes we travel to see and the photos we take. Cartography and navigation. Historically, sailors relied on cloud patterns to predict weather and winds. Today, satellites constantly image clouds, providing vital data for weather forecasting, climate models, and even mapping surface features obscured by vegetation. Understanding clouds is also key to understanding our changing climate. How will cloud cover, type, and altitude shift as the planet warms? This remains one of the biggest questions in climate science, with huge implications for future rainfall patterns and temperatures. Satellites and supercomputers are constantly working to unravel these mysteries. So, the next time you look up, remember, those clouds are not just passive fluff. They are dynamic, powerful forces. They are the sky's silent storytellers, weaving tales of evaporation and condensation, of heating and cooling, of the vast, interconnected systems that make Earth the vibrant, living planet it is. They are geography in motion, painting the canvas of our atmosphere. Thanks for joining me on this journey into the sky with the geographic eye. If you found this cloud dive fascinating, give this video a thumbs up, it really helps the channel. Subscribe and hit the notification bell so you don't miss our next exploration into Earth's wonders.